Hey everybody, welcome back, and thanks for joining me on this next installment of my quest for the ultimate crawler wheels. Hopefully you've seen the prior episodes, so you have some context and understand where I am in this quest. Don't forget to like and subscribe, but most importantly, turn on notifications. That way you'll be alerted when future episodes come out and we can see this journey through to the end together. To summarize, I want the highest performing 2-2 crawler wheel set with drop center hangers and beadlock. I'm not concerned about scale appearance or meeting any competition class. I just want to demonstrate the best possible climbing performance that physics will allow. This is my second prototype and it's starting to approach more closely what I envision the final version will look like. So let's check it out. On this channel, we look at the science behind our grown-up toys. So, after testing out this first prototype, or proof of concept, what did we learn? Well, even when things fail, you've still learned. You've learned what doesn't work. So there's a lot of things that didn't work great on this design that will help to refine and design the next version. First of all, what didn't work? Well, because the foam was exposed on the inside through here, it sucked up a ton of debris. I collected a huge amount of these weed seeds from designing out in the field. You know those burrs that get in your sock and they only go in one way? These were just polluted with all kinds of those. Maybe it's where I drove and maybe it's the time of the year where those things are super common right now out in the fields. But driving through those, I sucked up a bunch of junk. So ideally, the foam would be protected better from the inside from infiltration. The other thing is that I was kind of testing out these 5 starfish arms, and I wanted to see whether or not these edges would help catch and lift you over things. I couldn't really sense too big of a benefit to this, and in fact, in the first video, you'll remember that there was this bumping effect coming when the wheel was loaded. A lot of you suggested that that could be mitigated with a 3D printed insert that kind of contoured and smoothed out between these bumps. That definitely would be one solution. One of the big problems I had with this concept was that these things pinched right through my foam in a few spots. You can see right here. This got ripped and it's pinched through in a few other spots. So yeah, you can see it really tore up the foam out here. This is exactly where those spikes were. And it kind of got ripped and torn through there. So even though I tried to make these round and smooth, they still dug into the foam and had a detrimental effect. On the positive side, the way this is designed to pinch your bead worked out perfectly. These dimensions were absolutely perfect. I tested both Deluxe Goat and also some Proline Ibexes, and it clamped both of them perfectly. In fact, it might have been a little too tight. I'll probably make this outer ring thinner by maybe 1 or 2/10 of a millimeter, but the dimensions were almost perfect and it really clamped them perfectly tight. So I'm definitely going to continue with this geometry and this clamping configuration. Also, these bead locks worked perfectly. They were exactly the right size and they clamped down nice and tight. They didn't flex or bend, and with 5 bolts it worked really, really well. So I'm super pleased that I've got that portion of it figured out, because having a beadlock that works and reverse engineering that geometry to work with lots of tires is one of the big tasks at hand. Now another thing is this leaf spring that was on the inside. I don't know how great it worked. It's probably too much complication for what it does. If I'm being honest, I think a thin strip of closed cell foam or a 3D printed strip will probably do the same thing that this does with a lot less hassle. Also, one of mine broke. Once I took it apart, this just popped out. So this carbon just completely snapped. I don't know how or when or why, but it was broken when I opened it up. So maybe not such a great idea, at least not in this configuration. But I do have a couple other leaf spring ideas that I might explore still. As far as the hubcap, it didn't look as great as I thought it would, and covering these 5 holes looks clean, but it also makes it difficult if you have to change your hub spacer. You have to disassemble everything. So I'll probably open this up so we have the hex spacers accessible from the outside. Also, I had the weight hanger mounted to this. Worked perfectly. It was nice and stiff. And I've already got the carbon ones here. So that's the end of phase one, and I'm probably not going to use those parts anymore. Moving on to the next design. This is going to be the second prototype of my quest for the ultimate crawler wheel. I'll let you in on what my final vision for the product is. The final product I would love to look like this: one-piece molded carbon fiber. Most of what you see in RC and BattleBots and drones is flat carbon with the 2D machining. But I spent most of my career making hollow molded organic shaped carbon structures, mainly mountain bike frames. The technology is very common to make really cool, hollow, thin wall, full carbon structures like this. This is the perfect application for a crawler wheel. Making something like this requires tooling, and before we commit to tooling, we want to make sure we have all the details figured out, because it's harder to change the tooling later. So for this step, I'm going to try to simulate that hollow carbon structure out of a few smaller pieces of carbon. I've got some flat plates, and what I'm going to do is bolt it together with these U-shaped channels that were actually cut from a square, and that together will give me this U-shaped or hollow carbon structure. And that will allow us to dial in the diameters and the shape before we go towards a final product. So this takes quite a bit of work. It's got to be made out of 6 bridge pieces and 2 side plates. But let me put it together and show you how it works. So first of all, let me show you how I cut all these bridge pieces. I made a 45-degree miter cut on my DeWalt miter saw, and I ended up with this shape, made a whole bunch of little cuts, and then broke them all apart. To make these slits for the leaf spring, I used my compact table saw, very carefully fed it into the blade part way and back. Then for the other side, flipped it around, came in like this. And that's how I made these 4 slits for the leaf spring. After I had these cut out, I had to drill some holes. So I just took a piece of wood, drilled them like that. Then I took a Dremel fiber cutoff wheel and contoured these pieces out. Then I cleaned it all up with a Dremel sanding drum. Now I made a couple different bridge designs, but first let's put together this one. So I've got these nutserts pressed in, which will make assembly a lot easier. And this is going to bolt together like this. These are very easy to install. You simply drill the exact right size hole as prescribed from the manufacturer and hammer it right in place. This avoids the use of nuts and pliers that I used on the very first prototype. Nice. Now we've got threaded inserts, very low profile, stainless steel. This will make assembly a lot easier, and it's quite strong. And this is going to bolt together like this. So I'll have these bridges going across, simulating that single carbon structure that I'm dreaming of. Simulating that single molded carbon structure that I'm imagining. Now before we put the last bridges on, we need to make sure we put the weight hangers on the inside, because you can't really get them on afterwards. That's definitely a detail I've got to figure out, because if this were molded out of one piece of carbon fiber, you're going to have to figure out how to fish everything in through this one hole on the inside. For now, we can just slide it in. You'll notice that I did get this hanger cut out of carbon, and I'm working on potentially 2 different thicknesses. One is a 3-row, one is a 2-row. This one weighs about 130 grams, and this one weighs about 180 grams. I'm not sure how much space I'll have or what weight I'm going to want, so I've got myself 2 options to start with. Let's start with the heavier one because this will be a little more challenging ultimately. So put that in there, spin it around. Now I've got 2 more bridges to put on. Can you hear that windstorm outside? Very unusual for California. It's really shaking my garage door. Now I don't need 2 bolts on each side. I drilled this second hole, so I've got a hole to reach through and tighten the bolt. So I can just go through here to tighten the bolt on the opposite side. I'm using flathead bolts, so this carbon was countersunk, so on the inside, these bolt heads don't stick out. That's so I've got as much room as possible for the weight to sit down here. So on the inside are flathead bolts. I'm not sure if you can see those on the inside, but that's the bolt I'm putting on the inside. All right, I'm going to tighten these all up. Looks like I don't even need to hold the bolt on the back side. The friction of that countersunk head holds it tight enough. Dang it, I made a small mistake. So the outside plate is 2 millimeters thick. This one carries all the load from the hub adapter. So this is really the most structural plate. The inside plate is thinner at 1.5 because all it does is carry the bead lock for this half of the wheel. And what I did was I put 6 millimeter bolts in, and I should have put 5 millimeter bolts. A 5 millimeter bolt sits more flush. So I'm going to replace these 2 bolts with 5 because I accidentally put 6 in. I'm using a 6 millimeter bolt on this side and a 5 on this side. All right, so functionally, we now have a full carbon structure, although it may not look pretty because it's held together with a lot of nuts and bolts, but this should give us the basic performance that we're looking for from the final product, and this will help us to decide a couple more things. Number 1, how big should the outside diameter be? And also, should this outside shape have any features to it? As you can see right now, I've got these empty spots in between that'll make the foam more compliant. I'm not sure if that's good or bad, but we'll check it out. Now, I do have some other bridges here that I'm going to test. I have some much wider bridges. So you can imagine when I put this wheel together, these are going to make a much smaller gap between, and it's also going to make a bit of a point. So I'll have 6 peaks that act as paddles. You'll remember the paddle experiment from the first one wasn't that successful. These paddles are much lower, but I'm curious to see if these flat and then paddle sections are a benefit, or if it's a drawback like on the first one. Ultimately, we want to see if some shape other than round is conducive for this outer surface, or if just a round surface is the best. That's part of the study in this prototype. Now, one other thing I want to explore is, should this outside bridges, should they be springy? I'm kind of losing hope for the leaf spring concept. On the first prototype, you'll remember one of them actually broke, and on the other ones, it was, I don't know, not super successful. But I did make some bridges here that have leaf springs in them. Take a look at this. You've got this flex bridge right here. It'll be a little more clear when I put the whole thing together. Then I've got this one that has a shorter flex bridge on each side. So we'll give this one more go to see if leaf springs can offer any advantage. It will be possible to put leaf springs in the final single carbon shape if we want. But at this moment, I'm kind of leaning towards keeping it simple and just using some foam. But we're going to build one of each wheel, each direction. Now, what I'm going to do is put a thin layer of foam on each of these bridges. All right, so this foam is kind of on the thin side. But I'm going to put 6 squares on there just to kind of take the edge off. Now this is very firm closed cell foam. We're going to put an outer layer of foam on. Now if this were a long-term tester, to really make sure this foam sticks, what I would do is rough this up with sandpaper and then clean it with alcohol. Because this is a short-term prototype, pretty sure this will stick well enough as is. Now the key to any adhesive like this is you need to press it in place. A lot of people just stick it on and walk away, but you need to have pressure, usually 30 seconds. That pressure creates heat and allows the adhesive backing to really stick to whatever it's sticking to. Okay, so version 1 of 2, we've got this foam with the big gaps in between. What you can hear is a weight hanger rolling around in there. This will be anchored on later. All right, starting to take shape. Now the next step is these rings, which from the first prototype worked awesome. And this is half of the bead lock. And I do have these in 2 different thicknesses. I hear reports of certain tires don't clamp down tight on certain bead locks, and other bead locks are really hard to assemble and tighten down enough. So I think it makes sense to have 2 different thicknesses, or maybe more, of this particular ring so that you can control the amount of squeeze you have on your tire. The other part is what I'm calling the hubcap. And this is a departure from the first prototype, which had 5 Lamborghini holes in it. This has 6, I don't know, mag wheel cutouts. This looks surprisingly good, if I do say so myself. Now, this hubcap is a structural component. This is what sets the depth, the clamping depth of the bead lock. And here's the bead locks, 2.5 millimeter carbon with countersunk bolt heads. So on the outside, it's nice and flush. There's nothing to scrape or get hung up. So this hubcap is really the spacer that stops the depth and pinches your tire at a fixed amount. Also, this hubcap could be printed in different colors. Take a look at the difference between these two. This is MJF printing technology. This is bamboo FDM technology. And this particular vendor allows me to order vapor polishing. So look how smooth that surface is. It almost looks like a production injection molded part with a small texture on it. What I hate about 3D printing is you always get these layers, these lines. To me, this always looks cheap. I much prefer a printing technology or a smoothing technology that makes this nice and smooth. But I couldn't get this in orange, so I printed this off a bamboo printer. Structurally, it doesn't really matter for this part. All right. So this will go on together like this. We'll have one of these on the back side. And on the inside, this is the vehicle side. I just have a smaller spacer. That's so you can access all your fasteners in here. On the outside, we have the hubcap. On the inside, we just have a narrow ring. If you wanted to save weight, you certainly could use this narrow ring on the inside. Maybe you like the look of that better. Let's see the weight difference. This weighs 0 grams, and this weighs 7 grams. So I could probably save 6 grams if you didn't want the cosmetic center hubcap part. Either of these work. I could probably go back and make this hubcap lighter. 6 grams is not an insignificant amount, so I could put some pockets on the back side, make it a little bit lighter. We'll see. I'm just going to use these dirty old foams from the first test. No point in wasting them for a short prototype. So this is how it's going to look. And again, we've got sort of a rigid spot here, and then a softer spot here. So we've got 6 sort of paddle areas. Maybe it makes sense to have more paddle areas, less paddle areas, no paddle areas. I don't know. It's getting harder and harder to test which ones work. So we'll just try it this way and see what happens. All right, so probably makes sense. I'm going to use these Ibex again. These are pretty good all-around tires. Pretty well known, their performance. And pretty predictable. This is the softer tire compound. I've been experimenting running the firmer compound in the rear and the softer compound in the front. Somebody turned me on to that. If you want your rear end to break loose, and if you want a little bit stiffer sidewall, the firmer of the rear tire compounds will help you do that. It'll break free because it's a little less sticky, and also has a little bit stiffer sidewalls. The rear tires always have more weight on them when you're climbing up a steep hill. But I think I like the sticky nature of them, and I'll probably go back to running the sticky tire in all situations. All right, let's see if we can get this in here. These tires are pretty stretchy and pretty forgiving, but you do want to use a little bit of caution getting them in there. I did forget what bolt length I need. These should be 10mm bolts. Yeah. So now we put in the hubcap, line it up nice and pretty. You know, I think I'm going to start with longer bolts to pull this together, because this is just a little bit tricky. All right, so I used some 16mm bolts to pull it together. I'm going to go back and put in the final length, which is 12. Get those started. All right, take out the 16s. And put 12s back in. There's a little trick for any of your beadlock wheels. Start with a longer screw to pull it together, then replace it with the correct length once you're done. Always use a crisscross applesauce star pattern to tighten things down like this. If this were the final assembly, I'd use purple Loctite to keep these bolts tight. Even though you do have pressure from the rubber of the tire holding them tight, I don't like to take any chances. I would definitely put some purple Loctite on these. But this isn't going to be together for too many weeks or months. Same thing on the opposite side, only I'm going to use the smaller ring. I'll probably put some alignment features on this so when you drop it in, it finds its alignment spot. Right now, you have to find it yourself. Start with a longer bolt to get her going. This is way easier to assemble compared to the first one. That first prototype was a real nightmare, as you'll remember. But it wasn't supposed to be easy. All right. That looks pretty good. Now you can feel, here's the soft spot in between. Then there's a firm, soft, firm. Not sure if you can see that. Here's a softer spot, here's a firmer spot. Again, I don't know if this paddle concept is good or not. It's a lot more subtle on this design, and it will be even more subtle on the one with the longer bridges. So that'll give us two more options for evaluating if that interior outside shape should be perfectly round or if it makes sense to have some ridges of some sort. So to keep this from rotating as the leaf spring compresses, I'm going to put 2 bolts. And on this side, I'm going to put in the double leaf spring, although they're shorter leaf springs, so they're quite a bit stiffer. Now, if I hadn't already put the tire on the other one, we could look at them side by side. Hopefully, remember, this had a much bigger gap in between. So now what we have is much more pronounced points at each of these 6 locations and a smaller gap in between. And then I've got the leaf spring. This is the single-sided leaf spring. Yeah, that works pretty good. Wow, that's a lot better than I thought it was going to be. Now let's look at the dual leaf springs. Yeah, these are pretty stiff. Because it's only half the diving board distance, these are pretty stiff. So, not optimistic that this is going to give us much of a benefit. But this is pretty cool. So if I had these going all the way around, you'd have a soft spot, firm spot, soft spot, firm spot, all the way around. Again, kind of losing hope that this is actually any sort of benefit. Kind of leaning towards good old-fashioned foam. I will put some foam on all these surfaces. All right. Probably should have wrapped some foam a little wider on these corners, but we'll just run it like this. I do have more of the leaf springs. These were a pain to make. I could install these later. I'd be curious to see what happens with this longer leaf spring in all 6 locations. I'm going to see if I can get any sort of data that indicates this one location is beneficial or not before I commit to trying it in all the different places. All right, and again, going to have this dirty foam from the first test. I like that this foam adds some stickiness left and right, so this won't slide back and forth as much. All right, let's put the whole thing together. What I really like about the Crawler Innovations two-stage foam is the inner foam kind of flares up and fills in sort of this kind of hollow spot closer to the bead. So what I need is probably a tuning disc like this. This is probably a little too thick, and I did put these in the first prototype, but I didn't put them in this one. I think this foam is good enough for now, but I probably reinforce the sidewall with maybe a piece of foam that's thinner than this, or maybe some open cell foam to kind of fill in these sidewalls, because that inner cavity, and it's just kind of hollow right here. So I'd like to get some foam for there, but for now, I think this is pretty good. This feels a lot better on the outside already than that first prototype did. So now, put them on the rig, see if she crawls. So there's quite a big weight difference in these new wheels versus what I was running. That's because I've been kind of cheating by running these plastic wheels. These things are so crazy light. I think they're only 17 grams. We'll call it 18 grams per wheel. That is really light. Of course, they're glue on, but they're super strong. Not very glamorous, so not many people run them, but really one of my favorite wheels up until now. I'm designing this new set of wheels. So let's see what the total car weighs. If you've seen my other video, you'll know I do this poor man style with one scale. Let's see, better put the battery on too so the weight bias is accurate. Okay. I know you can't see it, but I'll write it down. And the rear is 1043. Now let's check the front. This is the front I was running with this 3-row weight hanger, and we also need some hardware and 4 spacers to be totally accurate. Okay, so each front wheel was 294. All right, not so bad coming off. So here's the wheel, weight hangers captured on the inside with all the hardware and screws necessary. And this is 380. Let me summarize all these numbers in one convenient table for us. So the new wheels weigh about 2,500 grams or 5.5 pounds. And the wheels I was running with weight hangers weigh about 2,300 grams or 5.1 pounds. That's about a 200 gram difference, or just under a half a pound heavier than it was. Now remember, this is a prototype, so it's got extra hardware, nuts and bolts. It's quite a bit heavier than the final product would be. So that's worth keeping in mind when we're evaluating it. The weight bias is 63-37. That's 63% of the weight on the front wheels. And the old setup was 62-38, so not too far off, pretty much the same. So I went out to the rocks behind my house where I've driven 1,000 times, and this version of my rig immediately climbed not one, but 2 lines that I've never made it up before. In fact, I'd given up trying these two lines because I've never been able to make progress on them. So I grabbed the camera and went back and got this footage. I've never made it straight up this line before. I've tried to follow that ledge to the left, but honestly, I've never made it up this side of the rock. Of course, everything looks less steep and smaller and easier on camera. On this rock, I usually have to start to the far left, get hooked on that shelf, and then traverse all the way to the far right, and then come up on the backside of that crack. In this case, I was able to go straight up the steep part, which is something I've never done before. Clearly, the rig is performing the best it ever has with these new wheels. The question now is which improvement helped the most? I violated my own testing protocol and I changed more than one thing at a time. First, the weight hangers put the weight lower. Second, the total weight went up quite a bit, but the weight bias stayed the same. And there's the question of the internal paddle shapes of the cross bridges. Finally, the fourth variable is some of those carbon bridges had the diving board leaf spring design. This is definitely a step in the right direction, and we're going to need more testing to understand the why.